Hello everyone. I'm Shashank. I'm the CEO and co-founder of ThreatShields, which is an cybersecurity, Web3 cybersecurity company. And we are more towards the automation side of things. Uh, Today we will talk about, it's like scaling automation security in Web3 using AI automation and what we have done and what we have achieved in this format of the game. So a bit about myself. I have been into security for almost 13 years, starting at the age of 14 when I found a bug in Google. And my name is listed in their Security Hall of Fame page. I also found bugs in Microsoft, Apple, 30 days in Apple iOS 10.3, and many, many more. My Web3 journey started with Avalanche, where I joined Avalanche team as a security engineer. And then later on, I started my own venture. So why smart contract security automation? So if you talk about the numbers, it's like numbers of hacks which has happened across. Let's take the numbers of 2023. $1.5 billion were lost in it's like smart contract related hacks, and out of which 55%, that is roughly around 700 million, was due to bugs in smart contracts. The numbers for 2024 is quite the same, somewhere around 1.44 billion, and same 55 to 60% of vulnerabilities in the smart contract, it's like logic or the code itself. These are the graphs which you can see, it's like $1.58 billion hacked across 420, it's like different hacks in 2023. Now, let's talk about the problem. The problem is, it's like it's pretty evident that we lose money, it's like we lose faith in blockchain as we get hacked. And the solution currently right now is, it's like manual audits, it's like multiple audits, bug bounty programs. There is one sort of lacking is, it's like if we expect blockchain to grow, we also expect security incidents to grow. And that's what we need to reduce. And this is something we can learn from, the Web2 security industry, where the talent has catched up, people have toolings, it's like people have better form of security and, it's like risk management, etc. So if we see the current, it's like Web2 security ecosystem, it comprises of, it's like a shift left approach where they implement, CI/CD security pipeline tools to remove like 60-70% of the vulnerability, and then they do a private audit, it's like, or maybe an in-house audit team which will take care of, it's like maybe 99% of security, and then for 0.1% or it's like 1% of the master class bugs, like a very edge case, that's where you launch a bug bounty program. And my belief is the same, the Web3 goes into same ways as well. We have Immunify to solve bug bounties. But again, if you directly go ahead with a bug bounty program, you will end up paying a lot of money, which is not good for a Web3 company for financial like purposes. And then it's like Web2 audits, Web3 audits, like competitive audits or something like that. That also it's like requires a lot of money as well. So how do you cut down cost? It's like you implement automation tools, then you go for a private audit, and then you launch a bug bounty program that makes your entire it's like financial cycle of spending in security lower, and it also increases it's like your security, because there is nothing such as like 100% security. So when we talk, and in this, it's like in this talk, I'm focusing more on scaling security, which is the first 70%. So there has always been a problem with it's like automation security is that with static analysis, writing detectors, you can reach 60-70% of security, but it always fails when it comes to business logic vulnerabilities. It's like bugs which can differ from application to application. And that's where, it's like the power of AI come into picture. And we'll do this we'll understand this entire thing through, a test case, it's like for an example case scenario. So in 2022, there was a company called Shadowfy, which got hacked, and, it's like the exploited amount was $316, it's like $1,000. Now let's understand the hack behind that. It was a very pretty simple attack, which it's like which could have been found using automation as well. So if we see the first transaction, the hacker tried to gain some it's like wrapped BNB. Then the hacker, I think made a test transaction to try and buy, zero point 0.5 ShadowFi tokens. And then the hacker bought, full amount of 9 ShadowFi tokens. Then we can see something happened and 10 million of the ShadowFi tokens were burned. This is where actually the vulnerability lies, but we'll come to the point later on. And then rest we can see the rinse and repeat where the hacker tries to sell 0.5 ShadowFi tokens and then sells whole lot of ShadowFi tokens and then converts it into BNB, taking a profit of $316,000. Now when we looked into the hack, we were obviously curious about the fourth one where 10 million tokens are getting burned. So our first guess would be the hacker found a way to burn the tokens, and which was actually the case. So if we see the contract code, line number 962, you will see the burn function was public, and this is a very, very simple bug which could have been found. Again, when we come to these things like why this was not identified, because there was no audit done. Why there was no audit done? Maybe they did not have enough money to fund the audit, or they did not want to do it. But these things, when we scale security, we bring the cost down through automation, and that's where these things could have helped. So when we saw this, we realized that okay, no, we need to automate access control vulnerabilities. If you see last year data as well, out of the 1.4 billion, 900K dollars were lost due to access control vulnerabilities, and it still remains, access control vulnerabilities still remain the top vulnerability for 2024. But automating access control vulnerabilities is not that easy. Let's see the problem. We tried to automate that on our Solidity Scan platform, and we did actually find the bug through automation. You can see bug ID 232. It says that okay, the burn function is public. But there is a catch here, since access control vulnerabilities are not remediated in, a singular fashion. People can have, Open Zeppelin's ownable module, they can have a required statement, they can have a custom RBAC. There are many other possibilities, right? So the problem here was, we were detecting access control vulnerabilities, but we were also detecting 24 others in same vulnerability in different functions. And those are false positive alerts. The scanner is not correct with, other, 21, 22 of them. And this was a big problem for us, trying to find access control vulnerabilities, because the false positives were much higher. So how did we solve that? That's where AI comes into picture. When you write general algorithms, when you write general algorithms, the problem with that is, you can write some cases, but then you cannot obviously write all the edge cases, all, required statements, if statements, find out RBACs which is in place. This is something an algorithm cannot do, because it will vary from contract to contract. Now, but with an AI, if we, send all the functions and the modifiers to an AI, or we create a RAG-based system with a vector DB, we can actually guide the algorithm to find the correct access control vulnerabilities. And this is what we did. By providing context to an LLM model, we were able to reduce the false positives by, you can see, in the next picture when we implement all these robotic figures with a small cross are actually invalidated by the AI, stating that there are certain, access controls in place. And then, the AI also confirms that bug number 392 is a valid vulnerability and rest are not. So you can see, in the next slide, you can see it says that, okay, this is an incorrect vulnerability because certain, access controls are in place. And the result was, the result was something like this. Without AI, access control vulnerabilities which were detected were 24, valid detection was 1, and false positives were 23. But with AI context, the implementation of RAG and a guided, tour of the algorithm to find access control vulnerabilities, we removed 19 false positives. That's a that's a reduction of 82%. So that's something we are actually working on. And what is next for the future of AI, in scaling, smart contract security, is we find more and more context. And how we do that is we read each and every modifiers, and then the modifier function is actually sent to the AI to understand the context. If there is any internal function or any external function call, we send that to the AI to understand the context, to validate if there is certain access control is in place or it is not. So thank you everyone for hearing. That was my talk. And if you want to discuss security, or if you ever want to talk about security, I'm available on Twitter or LinkedIn, and happy to respond. Thank you so much.
Any questions from the audience? If you want to have a question, just raise your hand.
Yeah, would love to answer any questions if you have.
All right, no.
Hey, good talk, man.
Thank you.
So, is this only for smart contracts on Ethereum, or do you also audit like Rust and other smart contracts?
So we are EVM compatible. So if you are anything on Solidity and EVM chain, this works. We haven't moved across Rust because of the demand. We did create something called rustscan.com with hardly 4 or 5 detectors. Maybe in the future, but currently we are focused on Solidity itself, and it works across all EVMs. So be it like Binance, be it Polygon, Avalanche, anything. We have support for almost 40-50 plus around 40 EVM chains, as we are partners with BlockScout.
Okay, nice, thank you.
Any other questions? All right. Oh, I'm sorry, I didn't see you.
For that. Hey Shashank, thanks for the presentation.
Thank you.
Did I misunderstand that you were intuitively or implicitly saying that you think like bug bounty security spend is inefficient and should be allocated away from that, ideally? Of course, in an ideal world, that will be the case. But
No, I didn't say that. So my understanding and belief, what I understand from from the Web2 perspective, because I spent 10 years there, is it eventually reduces your cost. For example, if you have kept a bounty of $100,000 for critical bugs, my point here is that should remain the same. It's just that you ensure that you don't pay up, five times of critical vulnerabilities, because you have patched them in the very early stage of your development. So that was my point. Thank you.
Any last questions?
And just to add, additional point to your question, that what also happens is that when you use automation tools in your software development lifecycle, when you reduce 60-70% of vulnerabilities, and when you go for a private audit, it increases the efficiency of that audit as well, because the auditors needs to be focused on on deeper vulnerabilities rather than something which is quite common. It has been the same thing with Web2 vulnerabilities as well. There was a time when cross-site scripting or SQL injections were everywhere. Now it's not. It's because most of almost all the companies have these SDLC tools, shift left approach, to automate those vulnerabilities and fix them during their development life cycle itself.
Yeah, the low-hanging fruit gets picked out first. Yeah. Awesome. Round of applause for Shashank.
Thank you guys. Thank you so much.